everybody. We're getting ready to do lesson 5.3 of Algebra 2, General Rational Functions, and it'll be part 1. If you need part 2, part 3, email me here to get that. 5.3, part 1, General Rational Functions. We got a class worksheet here of 24 points, and then 10 points of note-taking here. Teachers, here's your work for your students. Give them about 5 minutes, 6 minutes to graph these two functions here. Okay, welcome back. Here's the graph of number 1. The graph lies farther from the axes and the parent function. We are in quadrant 2 and 4. And then number 2 here, the domain is all real numbers except 7. Here's an asymptote here because of what's in your denominator here. This is a vertical asymptote, and the range is all real numbers except 0. Graphing general rationals, you've graphed rational functions involving linear polynomials. You will graph rational functions with higher degree polynomials. Graphs of rational functions that p of x and q of x be polynomials, but no common factors other than plus or minus 1. So here we are. Here we have a quotient here, and then they're all decreasing in value from your coefficients, and also as well as your exponents here. Everything decreases to the right until you have a constant. The x-intercepts of the graph of f are the real zeros of p of x, so they'd be the p of x. So the graph of f has a vertical asymptote at each real zero of q of x, has a vertical asymptote at each real zero of q and x. The graph of f has at most one horizontal asymptote, which is determined by the degrees of m and n of p of x and q of x. So when m is less than n, the line y equals 0 is a horizontal asymptote. If m equals n, the line y equals a to the m, b to the n is a horizontal asymptote. So we have two conditions here for horizontal asymptotes. Then if m is greater than n, the graph has no horizontal asymptote, and the graph's end behavior is the same of the graph of y equals a to the m x n minus n over b to the n. Well, what the hell will that mean? Well, here we are. Example 1, graph a rational function where m is less than n. The graph of y equals 6 over x squared plus 1, state the domain and range. The numerator has no zeros, so there is no x-intercept because there's no zeros in the numerator up here. And what about the denominator? The denominator has no real zeros either, so there is no vertical asymptote, so there is no horizontal or vertical asymptote. The degree of the numerator is 0, is less than the degree of the denominator 2, so the line y equals 0, the x-axis, is a horizontal asymptote. The graph passes through the points negative 3.6 and negative 1, 3. 0, 6, 1, 3, 3, and 0.6. These are all points on the graph. The domain is all reals, so we go in both ways for all reals. And the range is 0 is less than y, and y is less than or equal to 6. So we get this situation here. Okay, we're going to graph this function here. Students, this is on you. The guided practice will handle number 1. Okay, to graph this one here, the numerator has no zeros. There's no zeros up there, so there is no x-intercept. The denominator has no real zeros. There's no zeros here either, So there is no vertical asymptote. M equals 0 and N equals 2. So the M up here, the degree up here is 0, and N, which is the degree of the denominator, is 2. So M is less than N, and Y equals 0 is a horizontal asymptote. So Y equals 0, which is the x-axis, by the way. There's that. So we have a situation like we did in the previous example. We have a graph like this, where Y equals 0 or the x-axis is a horizontal asymptote. Then here's the table for that. You could put that into your calculator and get this table, or do it manually. Okay, example 2, graph rational function where M equals N. So the degree of the numerator is the same as the denominator. The 0 of the numerator, 2x squared, is 0, so 0 is an x-intercept. The zeros of the denominator, x squared minus 9, or plus or minus 3, so x equals 3 and x equals negative 3 are vertical asymptotes. The numerator and denominator have the same degree, so horizontal asymptote is 2 over 1, which equals 2. So that's horizontal asymptote. So what's this graph going to look like here? Plot points between and beyond the vertical asymptote. Here is a vertical asymptote here. Here is a 0 here at the origin. And then we have a horizontal asymptote here at y equals 2. Here is the graph of y equals 2x squared over x squared minus 9. And then here is the table here to the left of negative 3, between x equals negative 3 and x equals 3 here. This set of coordinates here, and then to the right of x equals 3 here. Okay, here's our next guided practice. Students, this one's on you. We're doing one now. So here's the table for this, 3x squared over x squared minus 1. We construct a table here. These are a table of values. When x equals 0, y equals 0. So we have something that goes through the origin. Here's the graph of it. It's split up like this, and then we have two vertical asymptotes here at x equals 1 and x equals negative 1. And then we have a horizontal asymptote up here. 3x squared equals 0, so x equals 0, so 0 is a x-intercept there. And then x squared minus 1 equals 0, plus or minus 1, so x equals 1 and x equals negative 1 are vertical asymptotes. M equals 2 and n equals 2, so m equals n, and y equals 3 over 1, which equals 3, is a horizontal asymptote. So here is our horizontal asymptote. Horizontal asymptote here. Okay, so that is our 5.3, part 1. If you want part 2 and part 3, and if you want worksheets, if you want online tutoring, get a hold of me here. Thank you very much.